Physics, chapter 17, theory, fifth video. Relating velocity and angular velocity. Relating velocity and angular velocity. Let's go through this note and see what they're trying to say. Think again about the second hand of a clock. Think again about the second hand of a clock. As it goes, second hand is, you are talking about the, seconds hand. Each point, as it goes round, each point on the hand has the same angular velocity. That means, now if you take the clock to be something like this, right? So now if this is the seconds hand, then each second it is moving. Like this, it is moving, right? So it goes like this. So then what they are trying to suggest is actually, now if you take the clock, now this is the way. Now if it is traveling from here to here, what it says is, now it would travel this point travels only this length from here to here. But if you take this point, it travels a higher distance, but at the same time it takes the same time for both of these points, this point A, this point B, both points to travel these lengths. It takes the same time because it is on the same hand. But point A moves a bigger distance from here to here, as you can see that. But point B travels only from here to here, which is a smaller distance, only a smaller distance. So as a result, they should have different speeds, because this obviously point A travels, the point A of the hand travels a bigger distance or a larger distance. In the same time, it has to have a higher speed, as you can understand. So now the point is, how do they relate the velocity, angular velocity, and the other velocities of the other points? How do they relate? So now, as we saw, different points on the hand have different velocities. The tip of the hand moves fastest. Points closer to the center of the clock face move more slowly, as you can understand that, because the tip has to travel a greater length. This shows that the speed v of an object traveling around a circle depends on two quantities: its angular velocity omega and its distance from the center of the circle r. We can write the relationship as an equation: speed equals angular velocity into radius v equals omega r. Now we have two equations. We know that omega equals delta theta divided by delta t, and now we have another equation for speed. Speed equals angular velocity into radius. So let's see this example, worked example 2. We'll go through this and write the note, and then we will see how easy how we can do the questions. Let's go through the question. A toy train travels around a circular track of radius 2.5 meters in a time of 40 seconds. So you have to understand, everything depends on what question they are asking. If they are asking for speed, you use v equals omega r. So you obviously have to find out omega then. But if they are asking for the angular velocity, then it is only omega that you need to calculate. So now omega equals, you have to read the question. There is a circular track of radius 2.5 meters in a time of 40 seconds. It travels around, they say. So that means 360 degrees or 2 pi is being traveled at 40 seconds. Then you have omega with you. Omega equals 2 pi over 40. I hope you understood that. Once again, if you had any difficulty there, it travels around a circular track. So that means the whole 360 degrees or 2 pi radians have been traveled in 40 seconds. So delta theta divided by delta t. Delta theta is 2 pi divided by 40. That gives you 0.157 rads per rad, right? rads per second, right? Rads per second. Here it is, they have given per rad, that is wrong. It's rads per second, obviously, right? Then we have to find the train speed. Train speed is calculated by the equation we just learned. V equals omega r. V equals omega r. V we do not know. Omega we just found out, 0.157 rads per second. Here it is a printing mistake. It should be rads per second, as you can understand, because radians are divided by seconds, rads per second. Omega is 0.157 multiplied by, then they are asking for the speed, V equals omega r. Then you have 0.157 rads per second multiplied by 2.5. So that gives you velocity is equal to 0.39 meters per second. Hope you understood that. You would have arrived at the same answer by calculating the distance traveled, that is the circumference of the circle, and dividing it by the time taken. Once again, the total distance divided by time taken, that is the speed. That also you would get the same answer.